Good morning, everyone. We're going to get started with the webinar now. I want to start by thanking everyone for joining us for this webinar. Better, what is the Building Efficiency Targeting Tool for Energy Retrofits and how can you use it? My name is Shannon Hilsey. I'm here with Natalie Tamir at the World Resources Institute, and we're very happy to be partnering on this webinar with our Building Efficiency Accelerator partners, Lawrence Berkeley National Lab and Johnson Controls, who have led the development of this tool that we're excited to present to you today. The Building Efficiency Accelerator is a partnership of more than 50 organizations and 50 cities worldwide, aiming to accelerate the rate of building efficiency improvement worldwide. You can find more information at buildingefficiencyaccelerator.org. We are excited to be presenting this rather new tool to you today, and our speakers will be Carolyn Szum from the Lawrence Berkeley National Lab and Clay Nesler from Johnson Controls, who will give us a little bit of an introduction to how this tool was developed. Just as a point of note, there will be time for questions after the main presentation is done, so please see the question box in the GoToWebinar module that's on your screen. You should be able to submit questions via text, both throughout the webinar and after, which we'll direct to the speakers once the presentations are done. If you have other questions about the content that are more appropriate for an email, please feel free to follow up with us, either myself or our speakers today. So thanks everyone for joining, and I'll now hand it off to Clay.
Great, thank you, Shannon, and good morning, good afternoon, and good evening to everyone dialing in for the webinar. My name is Clay Nesler. I'm the Vice President of Global Sustainability and Regulatory Affairs for Johnson Controls, and it is my great pleasure to provide an introduction to a little bit of the history behind the Better tool. History goes back about 8 years. We were looking for a tool that could be used for pre-screening and targeting buildings for retrofits. We have a very active energy retrofit business in North America, and often engage with universities, which have many buildings, school districts with many buildings, or with city governments. And we were looking for a tool where we could quickly take readily available data about the building, including monthly utility bills, information about the use of the building, the size, and certainly the location, and being able to quickly screen and target the greatest opportunities. We decided to leverage research that had been developed many years earlier by Professor Kissick at the University of Dayton in Ohio, which used inverse models as a way of identifying retrofit opportunities. And we, within our advanced development group, took this methodology and further expanding it to identify more specific measures on the order of 12 or 13 specific energy efficiency improvement measures using just a year or two of monthly utility bill data. While we were using the tool on hundreds of buildings to support our work, benchmarking and transparency and disclosure laws started entering into both a state and a city level in the United States. In this case, many cities and their building owners were required to enter in monthly utility bill data and assess their building based on its energy use intensity. In some cases, cities also required audits from professional engineers, but in general, building owners just received a score that said something like their building is in the 23rd percentile, which obviously is not good. 100% would be the highest performance building of that building type within that jurisdiction. So it occurred to us and Lawrence Berkeley Lab that this tool, based on the lean methodology, could be used to leverage existing data and target the buildings within a portfolio as well as specific improvement measures. So in the context of the Building Efficiency Accelerator, that's exactly what many of our cities are interested in doing. They're just starting to collect data. They're interested in benchmarking. They're interested in identifying retrofit opportunities, but in many times don't have the technical expertise to, say, do a audit or a more detailed assessment. This better tool allows them to take readily available data and identify the greatest opportunities, and perhaps more important, identify particular measures so they know which contractor should be contacted in order to do the assessments, whether it be lighting, HVAC, heating, building envelope, things such as that. So we decided to work collaboratively with Berkeley National Lab and ICF International, an energy consulting firm, and we created a cooperative research and development agreement to take our base intellectual property and put it in the public domain and make it usable, a very user-friendly web interface that those with some technical background, or potentially even those who just underwent training, could use to target retrofit opportunities. So Lawrence Berkeley Lab and ICF have been working diligently to put together an alpha version of that tool, which looks very, very promising. So I'm delighted to turn it over to my colleague, Carolyn Szum, who can walk you through the background on the tool, how it works, and how one would use it to advance energy efficiency initiatives within their city or within their portfolio. So Carolyn, over to you.
Thank you so much, Clay, for that wonderful introduction. So as Clay noted, I'm going to give you an introduction to the tool and basic training. So in terms of today's presentation, I'm going to give a short overview of the Better tool. I'm going to introduce you to the analytical underpinnings of the tool, and then walk through using the tool, inputting data, performing the analysis, and utilizing results. I'll also talk about our planned future developments. So first and foremost, I want to acknowledge Johnson Controls, who has worked collaboratively with Lawrence Berkeley National Lab and ICF under a cooperative research and development agreement to develop this alpha building efficiency targeting tool for energy retrofits. So as Clay mentioned, Better is an automated building energy efficiency targeting tool. It requires minimal data inputs and a short runtime to benchmark energy performance of buildings against peers, quantify energy and cost savings at both a building level and a portfolio level, and recommend energy efficiency improvements, ranging from quick no-cost and low-cost operational improvements to larger CapEx, OpEx expenditure type improvements. Better is a web-based open source software tool. The alpha version is available online at the URL shown. Our source code in Python is also available on GitHub for the developer community. As Clay mentioned, and I thought did a wonderful job sort of giving the context and history, Better, the genesis of Better is the ASHRAE inverse modeling toolkit, and early research done by Dr. Kelly Kissock out of the University of Dayton in Ohio, and the Johnson Controls lean energy analysis tool. So just a quick snapshot here. The value of Better to users is to provide building owners, managers, municipalities, etc., with visibility into the energy performance of their buildings. This is a no-cost, no-touch approach, and results from Better help to target and further focus energy audits and studies. The tool estimates the potential energy and cost savings in a single building in a large portfolio, and also provides specific energy efficiency improvement measures to help capture those savings. Importantly, Better allows property owners and managers to focus on buildings with the highest potential for energy and cost savings first. So a little bit about the analytical methodology of Better. And I'm going to go at this at a fairly high level, but this gives you an overall picture of the Better workflow. We're taking basic building characteristics such as size, location, building type, combining that with weather data available from the National Oceanic and Atmospheric Administration, NOAA, as well as monthly energy consumption and costs broken down by fuel type. That data gets pre-processed, and then we use an inverse modeling approach to identify a variety of coefficients associated with building energy performance. Base load energy performance, in other words, the weather independent electricity or fossil fuel consumption in a building, cooling and heating change points, which would be the temperature at which a building begins to consume either more electricity or fossil fuel for heating or cooling respectively, as temperatures either increase or decrease in the outdoor environment, and also cooling and heating sensitive consumption. So the rate at which a building is consuming either more electricity or fossil fuel as temperatures outside rise or fall. We take those coefficients of performance and leveraging Johnson Controls lean intellectual property, utilize algorithms to identify appropriate energy efficiency improvement measures, as well as to quantify energy and cost savings associated with those coefficients, and how they compare to larger data sets. All of that information gets combined and included in analytical output reports, which are available for users. So where I'll start here with is the data input requirements. So this slide provides a snapshot of what's required in terms of building characteristics, property characteristics. A user will need to indicate whether they want to work within the tool using imperial units or standard international units. In addition, they'll have to input unique building identifiers for each of the buildings they want to analyze, building name, location, gross floor area, excluding parking, the primary building space type, whether it's office, hotel, elementary school, etc., and the currency that they're going to input information using. In addition to this, a user will need to enter their monthly energy consumption and cost data for their building or buildings. At a minimum, 12 consecutive months of energy consumption is required, but additional years of data will provide more accurate results. Again, users would input the billing start and end dates, the energy type, whether it's electricity or natural gas, or chilled water, for example, or steam, the energy unit that pertains to the energy usage, as shown on their utility bill, the energy consumption, and the cost. I should note cost is optional. If a user doesn't have that cost information for whatever reason, Better will use default cost per unit of energy to do that calculation. The tool will automatically pull weather data associated with the billing period entered by a user from the National Oceanic and Atmospheric Administration, NOAA. I should mention that at the request of a number of our BEA partners, we are working on a feature that would allow a user to input their own unique weather station data. So for some of the cities that are in locations where there's not a local weather station that's entered into NOAA, this feature will provide more accurate and localized results. So I want to take a moment to talk about the data sets and property types that can be utilized with the Better tool. So Better allows a user to benchmark a single building's energy performance or an entire portfolio, if you have a corporate portfolio or a municipal portfolio. There are two modes of use. There's the option to benchmark your building's energy performance against a built-in reference data set, or to benchmark your building's energy performance within your own portfolio against your own data set. In order to use that feature, an individual user would need at least 30 buildings of an identical type to create their own portfolio and their own benchmark statistics for that internal benchmarking option. Currently, we have built into the alpha version of the Better tool reference data sets for offices, middle and high schools, and elementary schools. But we're working with Johnson Controls and others to build out a more robust benchmarking data set for other space types to be accessed. So I've talked a little bit about the data requirements, the options for benchmarking either against a reference data set or within your own portfolio. And now I'm going to just talk a little bit about what happens once a user enters data into Better. So the tool, as I mentioned earlier, will do some pre-processing of the data that's been entered, taking the building type, the address, the floor area information, as well as the monthly energy usage and cost data. The tool will then search for the closest weather station in the NOAA database. At the same time, it'll be combining different types of fossil fuel consumption and converting them into one unit. In this case, we've used kWh for simplicity. The tool will access the appropriate weather file from NOAA. It'll then normalize the energy consumption to show average kWh per day per square meter by month for at least the last 12 months for a particular building. The tool will then align and aggregate weather data with the energy consumption data using according to the billing periods entered by the user. As a result of this pre-processing, the tool will generate any one of the following inverse model types. And these are simple change point models that depict, again, the weather sensitive energy consumption in a building. I won't go into a lot of depth here, but I'm happy to take questions later in the call. But each of these inverse models will give us a variety of different model coefficients. As mentioned earlier, metrics such as baseload electricity consumption or baseload fossil fuel consumption, or it will give us the cooling and heating change points, i.e. the temperatures at which a building starts to, for example, the cooling change point would be the temperature at which the cooling system of the building starts to operate as outdoor air temperature continues to rise, etc. So we get a variety of these model coefficients. And then we benchmark these coefficients against our underlying data set or our built-in reference data set. So by way of example, we'll look at electricity baseload. Again, the weather independent electricity consumption in the building, which has a lot to do with energy used for lighting or plug-in process loads. In this case, let's say, for example, that we're taking the electricity baseload for this one office building, and Better will compare it to what we refer to as benchmark statistics. the median and standard deviation for electricity baseload in a larger database of buildings. We'll generate a distribution. In many cases, this will be a normal distribution, but not always. You can see one depicted here on the slide. And so we'll take the building that we're analyzing and we'll determine where within this distribution does this particular building's electricity baseload fall. If it's better than 1 standard deviation from the median, we would consider that good performance. Worse than 1 standard deviation would be considered poor performance, and anything in between would be considered typical. Electricity baseload, by way of example, falls less than 2 standard deviations from the median, i.e. better than 2 standard deviations from the median, good performance. We would do this benchmark analysis for all 5 of the model coefficients I described earlier, both for electricity and fossil fuels. So at a maximum, we could walk away with a maximum of 10 model coefficients to support analysis and targeting of energy efficiency opportunities. So moving beyond the benchmarking, we have some interaction with the user early on during the better analysis process. We ask users to specify the energy efficiency target they seek to achieve. If a user selects aggressive energy savings, we'll set targets a half a standard deviation better than the dataset median. If a user selects nominal energy performance improvement, we'll set targets equal to the dataset median. And if a user selects conservative energy savings, we'll set targets 1 standard deviation worse than the dataset median. With this information, Better will help to identify appropriate facility improvement measures or energy efficiency measures. So I'll talk a little bit about how this works in different scenarios. So let's take, for example, electricity baseload that we would consider poor, worse than 1 standard deviation from the median. A user has set a target as nominal. Because target is better than current performance, Better will automatically select appropriate facility improvement measures to improve energy efficiency in the building. In another example B, we have a model coefficient for electricity baseload that is typical. A target has been set as conservative, and because the target is worse than current performance, Better is not going to select any facility improvement measures. The next phase of the analytical methodology is calculation of energy and cost savings. And I'll talk a little bit about how this works using the example, in this case, not of electricity baseload, but let's say heating sensitive consumption for a building. Here depicted is an example, or depicted in the graphic here, we'll say that the heating sensitive consumption in the building is worse than the target. You can see a steeper slope moving to a more gradual slope. Because of this, some facility improvement measures are recommended by the Better tool to reduce coefficient associated with heating sensitive consumption and rerun the analysis to generate a model with that new coefficient. That will provide us with a lower estimated energy consumption for the building. We'll subtract the building's current energy consumption from that revised energy consumption, implementing all of those facility improvement measures, in this case, improved heating sensitive consumption, to get an estimated energy savings. We'll take that and then multiply by associated energy costs to get the overall cost savings for a building. Here's just a quick snapshot of the types of coefficients and their benchmark levels, i.e. are we seeing high electric baseload or high fossil fuel baseload, and what are the types of energy efficiency measures that will be recommended in different scenarios. So I've given sort of a high-level introduction to the better analytical methodology, but now really want to walk through what I think is most important to the BEA users today, and that is how do you use the better tool. So you can access better online at the URL shown. As Clay mentioned, this tool is currently an alpha version and is intended for pilot users. You can learn more about the tool on the home and how it works pages. But to get started, you'd simply click on that blue button there shown with a red outline. And first and foremost, a user would need to upload data. So you would click on the link shown in the red box to download the data entry template spreadsheet. This is a simple Excel spreadsheet, and enter the basic property information and utility data into the template as I described earlier in the presentation. There are detailed instructions for users on how to enter data into the template itself. Once all required information has been entered, a user will then save the spreadsheet to their desktop or their hard drive, use the Browse button on Better, and the Upload button to select and upload your saved Excel spreadsheet into the tool. The next step is to select the building type to analyze. So your input portfolio data will show as depicted in graphic at the bottom of the screen, graphic 2. Better can only analyze one building type at a time, i.e. office or hotel. And this is going to ensure that the results are meaningful and useful, since buildings are only being compared to other buildings of the same type. A user must therefore select the building type which you would like to analyze from the types that are represented in your uploaded portfolio. If your spreadsheet only contains one type of building, you'll only be given that option in the Choose Building Type drop-down. So once you've selected the building type you'd like to analyze, Better will provide you with a list of the buildings of that type from your uploaded portfolio. You'll use the checkboxes to select any number of them to analyze, from a single building to the full list. Clicking on the checkbox in the header row will select all buildings in the list itself. As I mentioned earlier, a user will need to select the analysis settings they'd like to use. So a user will need to select their savings target as well as their benchmark statistics, as shown in the options below. So for example, aim for nominal energy savings in their building and portfolio, aggressive or conservative, by choosing one of the radio dial options. They'll also need to determine whether they want to benchmark against a built-in reference data set, which is the default option, or if they want to generate their own reference data set and individualized benchmark statistics. In order to use that generate option in the benchmark statistics field, a user would need at least 30 buildings of an identical type. And I'm happy to answer more questions on that option as we go forward. So once a user has entered data and made the appropriate selections regarding targets and benchmark options, they'll run analysis and review results. So very simply, they'll click the Run button in Better. This may take a few minutes depending on the number of buildings being analyzed. Once that analysis is complete, the resulting output report will the resulting output report link will appear for a user. This will either be a single building output report if only one building is being analyzed, or an entire portfolio report if multiple buildings were selected. So a user will then click on the link, and the appropriate report will be generated. So I'll give an example. If a user has input an entire large portfolio of buildings In this example on the screen, about 32 office buildings have been entered into the tool. A portfolio summary report is generated, which includes the number of buildings, the total floor area, annual electricity and fossil fuel consumption for that portfolio, annual cost for electricity and fossil fuel, as well as the site energy use intensity by fuel type. A graphic will also be depicted, which you can see in the lower left here, which provides an overview of the portfolio's energy performance and savings opportunities. On the x-axis, we have each of the 32 buildings, in this case offices, in the portfolio. On the left y-axis, we have energy usage intensity. The blue bar would be the electricity use intensity, and the red bar would be the fossil fuel use intensity. On the rightmost y-axis, we have the savings potential, in this case in dollars. The green bars depict the level of savings potential. So this gives a quick snapshot and an easy way to identify those buildings which represent the best opportunities to save energy and money, as well as those top performing buildings that may offer lessons for the rest of the portfolio. You can click on any one of those individual buildings shown in the report to do a deep dive analysis within Better. An analytical report as follows will be generated, which shows, again, for that particular building you clicked on, the gross floor area, the electricity and fossil fuel consumption over the past 12 months, or the most recent 12 months input into the tool, again, associated costs, and associated site energy use intensity. Savings potential, as well as potential energy savings, and a list of energy efficiency recommendations are also shown. Going deeper into that report, we also show monthly energy consumption by fuel type in the graphics at the very top of this third output report, compared to what could be achieved in the green line if energy efficiency measures were undertaken in the building. And I'll talk about that more in a moment. We also show the weather sensitivity and benchmarks. In other words, those inverse models, the change point models that we spoke about earlier, the model coefficients, and how those model coefficients compare to the larger data set we've selected, so benchmarks. Finally, we give energy efficiency recommendations, high-level information associated with what energy efficiency and opportunities to pursue and how to implement those. So once again, utilization of results. I'll say that we're putting a lot of focus in the type of information displayed within our analytical output reports to make it useful for users who are either trying to make the business case for energy efficiency or be able to carefully quantify their energy and cost savings potential. So here we have utility cost breakdown showing potential cost savings by base load consumption or energy used for heating or energy used for cooling. As I mentioned, the energy efficiency opportunities are also described within the report. We provide resources with additional guidance on how to implement or pursue these energy efficiency improvements. Some are, as I mentioned, quick and easy to implement. They can be undertaken at no or low cost by an in-house engineering team. Others would require, as Clay mentioned, appropriate contractors to implement the upgrades. Again, utilization of results. We have features here which provide opportunities to look at the monthly energy consumption in a particular building. You can see that in the lower graphics on the yellow line graph. These as compared to what could be achieved if energy efficiency improvements were pursued. I've talked a little bit already about how results are generated, but to dive a little bit deeper here, again, the heart of this tool is the inverse modeling combined with the energy efficiency mapping. So we're using basic energy consumption data that's being input by a user to create an understanding of the average daily energy consumption for a particular fuel type in any given month that during the year. And then we're plotting that against the average daily outdoor air temperature, generating these schematic plots. Here we have an electricity change point model, and we get these coefficients, the base load, the weather independent electricity or fossil fuel consumption in a building, the cooling or heating change point, the temperature at which electricity or fossil consumption begins to rise or fall as outdoor air temperatures increase or decrease, and then the cooling or heating sensitive consumption, which is the slope. How quickly does the electricity or fossil fuel consumption increase as outdoor air temperatures change. We do the benchmark analysis, which is depicted in the reports. I want to take just a moment to talk about interoperability. Better exists within a larger ecosystem of publicly available web-based tools to support building energy analytics. Foremost among these is the Energy Star benchmarking tool or Energy Star portfolio manager tool, which is used by more than 30 jurisdictions in the United States to participate in benchmarking and transparency ordinances. We've ensured and are working on a capability that allows a user that has portfolio manager account with data entered into that account to generate the Excel-based output reports in a certain form, easily read. A user to generate a specific in portfolio management, deeper analysis, energy efficiency, and we're also working, which would allow retrofit and platform abilities to be able to using render that data in any format they choose within their energy management platform or their own analytical tools. Future plans, we're continuing to work on verification and validation. This is really important that we ensure the technical viability of Better. We have a timeline and some steps there. Also continuing to build out our web app. As I mentioned, adding a capability for a user to input weather data from our local weather station versus relying only on data uploaded into the NOAA database. We'll make some user interface improvements, continue to refine and test our data transfer capabilities, and we're investigating the possibility of a green button data transfer as well. Here's the reference. Here are the building space types that we're targeting for our reference data set within Better. Initially, we're focusing on offices and K through 12 schools where we've had a tremendous amount of interest in using the Alpha Better tool. And here are some of our pilot project participants, a range of cities, states, corporations, and of course the Building Efficiency Accelerator. So this is what I have for today. I think I went a little long, and I think perhaps I've lost Clay here, but very happy to take any questions in the last 15, 20 minutes that we have.
Clay's still on, by the way, for about 5 minutes.
Oh, great. Okay, wonderful, Clay. So this is really all I have today. And again, very happy to take questions. And I know Clay has about 5 minutes to do so as well.
Great. Thanks, Carolyn and Clay. As a reminder, everyone, the questions panel in the GoToWebinar, the questions panel in the GoToWebinar node on your screen allows you to ask questions that we can direct to the presenters. I think we'll begin, we sort of covered this in the content, but perhaps you could reiterate, Carolyn, who is the target user for the Better tool?
Sure. So the target user for the Better tool is really, I think I'll address this question in two ways. The target audience primarily has been participants, either stakeholders that are involved or facilitators of the benchmarking and transparency ordinances that exist within the United States here, so covering about 30 jurisdictions. That has been one of our core target audiences. But in addition to that has been any owner, manager, operator of large building portfolios. So for example, organizations such as C.B. Richard Ellis or Blackstone Private Equity that either own or manage large portfolios. That's been another core audience. I would say thirdly, school districts. We've gotten a lot of interest from various school districts that again have responsibilities for the energy performance of a large number of buildings of a similar type. Better is really ideal for, again, municipalities, particularly those that may be faced with legislation currently or in the not too distant future, which will require them to either benchmark and report their energy performance. And in particular, we see legislation emerging in places like New York that are capping emissions levels in buildings, and Better is a perfect tool for those customers and clients as well. So those are a few of what I see as target users of Better, and of course BEA, where we've got cities around the world that are setting targets and seeking to improve energy efficiency, and Better as a fully data-driven approach makes that easy and cost-effective. And because we incorporate a combination of no and low-cost energy efficiency measures with measures that require procurement of contractors, it allows cities to get started right away, generate some energy and cost savings from those operational improvements that can be used then to make larger investments, CapEx and OpEx in energy efficiency.
Thanks, Carolyn. Great. We have a few other questions that are all in the same vein, which is around the how applicable or usable the Better tool is in different locations. Maybe you could provide some examples of places where it's been tested or used, and whether there are any constraints on which geographies can use it.
Great question. So we've designed Better to be able to be used in any jurisdiction, anywhere around the world. And the reason it can be used in any jurisdiction around the world is because the tool automatically normalizes for differences in weather and climate that exist. And because of that, we're sort of factoring out differences that may exist. We're sort of factoring out that critical driver of energy consumption in buildings. So the science of Better is that any building anywhere in the world can use the tool. Secondly, I would say that we're working on a feature that allows a user to input their own local weather data. In our alpha testing, we've noted that NOAA database, while very expansive, is not 100% comprehensive. And weather data is a very important input into the tool that has implications for the results. So this feature would allow, for example, buildings in Colombia to input data, weather data from very localized nearby weather stations to their building stock outputs. So we've been partnering with BEA for about, I would say, a little over 6 months, actually probably closer to 9 or 10 months. And we've had pilot users in Colombia, Mexico, I believe Turkey. So jurisdictions outside the United States are very much encouraged to use Better. We also have a great partnership with China, and they're keen to be using this tool as well.
Great. And kind of related follow-up question just on whether the benchmarking data, where does it come only from Portfolio Manager, or my understanding is that there's benchmarking data for other locations, but can you speak to that?
Sure. So the benchmarking data, I think there's two ways to look at benchmarking data. The first is that LB&L, in collaboration with Johnson Controls, is doing a lot to create underlying data sets, what we would call reference data sets, in order to derive representative benchmark statistics. That data is coming from a variety of sources, Johnson Controls being one of them, our CRADA partner, and some of the cities and districts and corporations that are our pilot partners. So the cities and organizations I showed on the second to last slide, a lot of these groups are providing us with data that's going into our reference data sets. So that's where we're gathering our reference data from. The data that, that gets analyzed, i.e. when a new user comes to use the Better tool, their data can already be in Portfolio Manager and then exported into our tool automatically, or it can be that they've simply got a spreadsheet where they keep their own utility bill information or their most recent utility bills. So I hope that answers the question. If not, let me know and I can clarify.
All right. Another question I know we've heard before, can users set specific targets rather than using the preset options for target levels?
Not yet. We just at this point have those 3 preset options, but certainly something we could look into. That's a very interesting question. Like, what would you need to do to get to 20% savings, for example? That's a very good question. I think that's something we can definitely look into, and I'll make a note of that.
All right. Another question: is there a minimum size for analyzing a building? Size.
Great question. Great question. In fact, we don't have a minimum size because we do normalize by size, and we work with energy usage intensity versus overall consumption in the analysis. Any size building can use the tool.
Okay, moving right along, questions keep coming. Can buildings how many types of building can participate? We mentioned office buildings and schools. Will it be available for residential, etc.?
Great. So another really good question. So on this slide, if you can see my slide deck, I show the reference data sets that we're working on establishing. So in the current iteration of the tool, we have reference data sets and statistics for offices and K through 12 schools. But we have data from JCI and other organizations for the additional space types shown on this slide. So we're in process of creating reference data sets for all of these additional space types. So that's I think, one part of the answer. In terms of residential, we're not going to look at single-family residential, but if we were to work with an organization that could help us build out a data set for multifamily residential, yes, that would be an additional space type we would add into the better space types. But we don't yet have that partnership established, so I haven't featured that as one of our focus space types. That being said, any space type can be benchmarked in Better by using the option to create or generate your own benchmark statistics. As long as a user has, we suggest at least 30 buildings of an identical type, i.e. multifamily, they can use that generate option to create their own underlying database and benchmark statistics and do internal benchmarking within their own portfolio. It won't be as compared to a larger data set. So until we have a partner that can provide us with sufficient data for multifamily, it would have to be an internal benchmark analysis only.
Okay. The next question, does the Better tool use incremental cost as a criteria for suggestion?
That's another great question, and it's not the first time we've heard that. We don't take, excuse me, we don't take into account the cost of measures when we make our recommendations. We are only looking at, you know, what would be the savings, the potential savings associated with improvements in energy efficiency. So in that case, no, we're not looking at the incremental cost at this point. But what we will do in the next iteration of Better is break down the savings potential into either no cost and low cost, i.e. what you can achieve at either zero cost or very minimal cost, versus what savings would require greater expenditure. So we will do kind of a rough breakdown for users, because we've gotten some feedback that would be valuable.
Great. Another question, what are the other relevant model coefficients which can be considered with the tool?
Okay, so I will just jump back to one of my earlier slides here to talk about the model coefficients. Buildings, or even familiar with the Energy Star Portfolio Manager tool, know that there are a number of drivers of energy performance in a building. You know, energy usage is a factor of the building's size, its location, the weather and climate conditions, occupancy, operating hours, plug-in process loads, etc. An Energy Star Portfolio Manager benchmarking tool has developed a methodology to normalize for all of these factors, these external factors that contribute to energy usage, to allow buildings to be compared on a level playing field, such as the building that has a high energy consumption may not necessarily be an inefficient building if it also has a huge occupancy level, significant operating hours, etc. So Energy Star Portfolio Manager takes into account all the various factors that contribute to energy usage in a building, normalizes to do a fair comparison one building to another in the marketplace. The Better tool takes a different approach. Really, we're just looking at a couple of factors, and we're using, again, building off the early research of Dr. Kelly Kissock, such that we're trying to understand the weather sensitive energy consumption of a building. So we're only really normalizing for two factors here. One is size. So we're doing comparing one building to another building based on its energy usage intensity. And also we're doing normalization of weather by plotting energy usage or energy use intensity against outdoor air temperatures. We get the schematics shown here, which are described in more detail in the ASHRAE Inverse Modeling Toolkit, which simply gives us just a picture, a depiction of the weather sensitive energy consumption in a building. We get, again, just in this case, 5 model coefficients, 5 for electricity and then 5 for fossil fuel, 10 in total. But this is how we're working within the better framework. Again, just these 5 coefficients to do the analysis. So hopefully that answers the question, but I'm happy if someone wants to email me and talk further, I'm happy to do that.
Great. I think we have time for one more question, which is, we had a question on basically how a city can get started. Let's say you're a city government with a portfolio of municipal buildings, maybe a lot of them. Mm-hmm. What do you recommend as first steps for someone who's interested in getting started with their portfolio?
Great question. So what I would recommend is to go to our website where there's additional information on the tool. There's a training presentation very similar to this that provides stepwise guidance on how to use better. And then we also have a how it works page. But I would say once you've familiarized yourself with the website and the tool, the most important first step would be to aggregate your data and input it into Better. And you can use one of two options. The other option is to use our Better Upload template, and we simply suggest populating that template with a subset of your building stock or all of your building stock, and then running the analysis. Thirdly, please email us. We'd be happy to talk further about how we could help you, do a pilot using Better.
Okay, thank you. I think we covered most of the questions, but we're unfortunately now out of time. So, or fortunately, because I'm glad everyone's so interested and engaged. So please follow up on Carolyn's suggestions or follow up with us via email with any other questions. The webinar is being recorded and we will post it probably at least on a couple of our websites. So stay tuned for follow up on that. If you'd like to reference the materials later. Thanks everyone for joining, and a big thanks to our presenters today.
Thanks, Shannon. Thanks everyone. We look forward to working with you on Better going forward.
Thank you so much. Thanks. Bye everyone.
Okay. Thanks everyone. Bye-bye.